Hello everyone. Today we are going to learn a potentiometer. Potentiometer is an instrument which is used for measurement of potential difference or potential difference between the 2 points can be accurately measured with the help of potentiometer. Potentiometer consists of a long uniform cross-sectional wire of length 2 to 10 meter. This wire, which is fixed between the 2 points on the wooden board, a scale is already marked on the wooden board. That is a source of electromotive force E, which is connected between the 2 points of the potentiometer wire, that is A and B. We have to explain the idea about the principle of potentiometer. For this case, we have to use this electrical network. Let I be the current flowing through the wire AB. R be the resistance of wire AB. L is the length of wire AB. And VAB is the potential difference between the point A and B. Then according to Ohm's law, potential difference between the point A and B is given by VAB is equal to I into R. Therefore, we have to find the value of I is equal to VAB divided by R. Let sigma be the resistance per unit length of the wire. That is, sigma be the resistance per unit length of wire. Therefore, R is equal to sigma into L. Substitute this value R is equal to sigma L in this equation. Therefore, I is equal to VAB divided by sigma L, equation number 1. Consider a point P. Consider a point P situated at a distance L or at a length L from the point A. Then potential difference between these 2 points is represented by VAP. And according to Ohm's law, VAP, potential difference between the point AP, is equal to I into R. Let sigma is equal to resistance per unit length. That is, L is the length, R is the resistance of the wire of length L. Therefore, sigma is equal to resistance per unit length of wire. Therefore, R is equal to sigma into L. Therefore, substitute this value R in this equation and the value of I is equal to VAB divided by sigma L in this equation. Therefore, VAP is given by VAP is equal to VAB divided by sigma L into sigma L. Okay. Here, sigma get cancelled. Therefore, VAP is equal to VAB divided by L into small l, that is the length of wire between the point A and P. As VAB divided by L is constant. VAB divided by L is constant. Therefore, VAP is proportional to L. Therefore, VAP is equal to K into L, where K is constant called potential gradient and which is equal to potential difference per unit length. From this equation, we have to explain the principle of potentiometer. The potential difference between the 2 points, of the wire is directly proportional to the length of the wire, provided the wire is uniform cross section, the temperature of the wire is same and the current flowing through the wire is same. This is the principle of potentiometer. We have to explain the uses of potentiometer. The first use of potentiometer to compare the electromotive forces of two cells by separate cell method or individual method. This is the electrical network for comparison of electromotive forces of two cells. In this circuit, the eliminator E, whose magnitude E is greater than E1 and E2, that is battery of electromotive force E, TK and rheostat RH, connected in series between the wire AB. Positive terminal of cell E1 and E2 connected to the point A. Negative terminal of the cell which is connected to the two-way key and sliding jockey through the galvanometer. Now, we have to explain the procedure of the comparison of the electromotive forces of two cells. Now, key K and K1 closed. Therefore, cell E1 is in the circuit. Then electromotive force which falls on the wire, therefore tap the jockey over the wire AB and find the point of contact D, at which galvanometer shows the null deflection. At that time, electromotive force of cell E1, which corresponding between the length of wire between the point A and D. Suppose that L1 is the length between the point A and null point D. Therefore, electromotive force E1 is proportional to length L or L1. Therefore, we have to write E1 is equal to K into L1, where K is constant potential gradient, equation number 1. Now, close the key K2, open the key K1. Therefore, cell E2 in the circuit, therefore potential of cell E2 falls on the wire. Tap the jockey over the wire AB and find the point of contact D dash, at which galvanometer shows the null deflection or zero deflection. Measure the length between the point A and D dash. That length is equal to L2. This length L2 due to the electromotive force of E2, therefore E2 is proportional to L2. Therefore, we have to write E2 is equal to K into L2, equation number 2. Divide equation 1 by 2. Therefore, we have to write E1 divided by E2 is equal to K into L1 divided by L2. K get cancelled, therefore E1 divided by E2 is equal to L1 divided by L2. With the help of this formula, we can compare the electromotive forces of two cells by separate cell method. Any one of the electromotive force is known, we can determine the another electromotive force. This is the first use of the potentiometer. Now, we have to explain the second use of potentiometer. Second use of potentiometer. To compare the electromotive forces of two cells by sum and difference method. Here, what is meant by sum method? The negative terminal of first cell connected to the positive terminal of second cell and so on. In this case, the electromotive forces is added together E1 plus E2. Such arrangement is called as the sum method. What is meant by difference method? In this case, negative terminal of first cell connected to the negative terminal of second cell. In this case, there is a electromotive force E1 minus E2. Then we have to explain the comparison of electromotive force of two cells by sum and difference method. This is the electrical network for the sum and difference method. The cell E1 and E2 which are connected in the sum method, these cells are connected in difference method with the help of key, jockey and galvanometer. Eliminator E, key K, rheostat which are connected in series between the point A and B. Now, close the key K and K1, open the key K2. Therefore, electromotive force E1 plus E2 which falls on the wire between the point A and B. Tap the jockey over the wire and find the point of contact at which galvanometer shows the zero deflection or null deflection. Measure the length between the point A and D. That length is equal to L1. Therefore, E1 plus E2 is equal to or which is directly proportional to L1. Therefore, E1 plus E2 is equal to K into L1, equation number 1. Now, open the key K1, close the key K2 and K. Therefore, the cells which are connected in difference method which are in the circuit, therefore, there is a fall of potential on the wire which is equal to E1 minus E2. Tap the jockey over the wire and find the point of contact at which galvanometer shows the null deflection. Therefore, electromotive force falls on the wire, which is given by E1 minus E2 is equal to K into L2, equation number 2. Divide equation 1 by 2. Therefore, we have to write divide equation 1 by 2. Therefore, we have to write here K get cancelled and E1 plus E2 divided by E1 minus E2 is equal to L1 divided by L2. With the help of this formula, we can determine the electromotive forces by sum and difference method. Also, this equation can be written by comparando and dividendo method. Therefore, we have to write E1 plus E2 plus E1 minus E2 is equal to L1 plus L2 whole divided by E1 plus E2 minus of E1 minus E2 is equal to L1 minus L2. Therefore, E1 divided by E2 is equal to L1 plus L2 divided by L1 minus L2. With the help of this formula, we can also determine or compare the electromotive forces of two cells by sum and difference method. Here, one of the electromotive force is known, another electromotive force can be determined. Next, we have to explain the third use of potentiometer. The third use of potentiometer to determine the internal resistance of cell. This is the electrical network for determination of internal resistance of cell. This circuit consists of battery of source of electromotive force E, key K1, rheostat RH, which are connected in series. The cell E1, whose internal resistance is connected in the circuit, that is positive terminal connected to the point A, and the negative terminal of the cell which is connected to the sliding jockey through the galvanometer. The resistance box are key K2 which are connected parallel to the cell E1. Now we have to explain the procedure of this experiment. Close the key K1, open the key K2, pass the current through the circuit, adjust the rheostat. In this case, the resistance is not in the circuit, therefore there is no current flowing through the circuit. Only the potential of the cell fall on the wire. At that time, tap the jockey on the wire AP and find the point of contact at which galvanometer shows the zero deflection or null deflection. In this case, potential fall on the wire between the point A and P of the length is equal to L1. Therefore, potential is equal to E1 is equal to K into L1, equation number 1. Now, close the key K2. Close the key K2. Therefore, electric current which flowing through the resistance R or resistance box is in the circuit. In this case, slide the jockey or tap the jockey over the wire and find the point of contact P dash at which galvanometer shows the zero deflection. At that time, resistance box in the circuit, the potential drop across the wire due to the terminal potential of the cell, and that is equal to V is equal to K into L2. L2 is the length between the point A and P dash where the potential, terminal potential of the cell fall. Therefore, divide equation 1 by 2. 1 by 2. Therefore, E1 divided by V is equal to L1 divided by L2, equation number 3. Let V be the potential drop across the resistance R. I be the current flowing through the resistance R. R means the resistance box. R is the internal resistance of the cell. Then we have to write here in this loop. We have to write in this loop according to KIRCHHOFF'S law. That is, we have to use the loop P, Q, R, S, P. In this loop, we have to apply the KIRCHHOFF'S law and we can write E1 is equal to I into R plus I into small r. E1 is equal to I into R plus R. Therefore, I is equal to E1 divided by R plus R. According to Ohm law, V is equal to IR. Substitute the value I is equal to this. Therefore, V is equal to E1 divided by R plus R into R. Therefore, we have to write V divided by E1 is equal to R divided by R plus R. Therefore, also we have to take reverse. E1 divided by V is equal to R plus R divided by R. E1 divided by V is equal to 1 plus R divided by R. Equation number 4. From equation number 3 and 4, we have to write 1 plus R divided by R is equal to L1 plus L1 divided by L2. Therefore, R divided by R is equal to L1 divided by L2 minus 1. Rearranging the term, therefore, R is equal to R into L1 minus L2 divided by L2. With the help of this formula, we can determine the internal resistance of the cell. Now, we have to explain the application of potentiometer. The first application of potentiometer is voltage divider. Second application is audio control. And third application is the potentiometer as a sensor. Voltage divider is the first application of potentiometer. The potentiometer can be used as a voltage divider to continuously change the output voltage of a voltage supply. Second, audio control. In this case, sliding potentiometer are commonly used in the modern low power audio control devices. And third application, potentiometer as a sensor. If the slider of the potentiometer is connected to the moving part of the machine, it can work as a motion sensor.